Today we're going to be looking at an enzyme known as bromelain, which is present in pineapple. And we're going to look at the enzymatic activity of bromelain from the pineapple based upon its ability to inhibit the polymerization of Jell-O. So Jell-O, which is something we've all grown up with, is made up of collagen fibers and it forms a triple helix. The enzyme in pineapple, bromelain, is able to cleave the collagen fibers such that the Jell-O will not solidify. So if the enzyme is active and present, it will inhibit Jell-O solidification. If the enzymatic activity has been inhibited, then what we will see is that the Jell-O actually solidifies. So the way that we're doing this experiment, we have 3 test tubes, one that's going to have Jell-O alone, one that has fresh pineapple, and one that has canned pineapple. The reason we're using canned pineapple is that in the processing of the pineapple, it gets heated up to a high temperature. And we've already talked about the 4 levels of protein structure in this class: primary, secondary, tertiary, and quaternary. And we have also discussed the fact that heat is able to cause a compromise in the structure of secondary, tertiary, and quaternary structures. So if we can degrade the enzyme, then we will be able to see solidification of the Jell-O, which is what we should see with the canned pineapple. So I'm going to go ahead. I have this Jell-O that I made a while ago. It's on a heat plate, and I'm stirring it so that it will not solidify. And what we're going to see is how fast does the Jell-O solidify for these different samples. So I'm going to use an aspirator bulb, which we would have shown you how to use in lab, but since we are not meeting in lab, we are not able to do that right now. And what I'm going to do is go ahead and put 4 mils of Jell-O into each tube. Okay, and go ahead and turn this off. And now we put our 3 tubes into an ice bucket. And what you and your partners would normally be doing is we start at 3 minutes, and then every minute thereafter, you look at the solidification of the Jell-O and whether or not it's still a liquid, partially solid, or fully solid. And so what you might hypothesize is that the Jell-O without any pineapple should solidify potentially the fastest. The Jell-O with the fresh pineapple should not solidify, or it might take a really long time. We stop this experiment after 20 minutes, and oftentimes the bromelain, if it's a really fresh pineapple, actually will never solidify that Jell-O. It'll stay liquid the whole time. Whereas the canned pineapple usually should, if the bromelain's been fully denatured, you should get times fairly close to the Jell-O alone. So we're going to give you some data to analyze for this week, and then what you are going to do in your groups is actually propose a method by which we can denature the bromelain, and we will vote on that as a class, and then I will actually conduct that experiment for my section, or Dr. Durrell will conduct it for his section, and we'll actually do the experiment for you. So I want you to begin to think about what are the different ways that I can cause denaturation of a protein. We're using heat right here, which is in that canning process. There's lots of ways to heat up a pineapple. You might want to propose something along those lines. We also can talk about changing salt concentrations, high acids and bases. Those can also cause denaturation of a protein. So you'll strategize in your groups how we want to denature the bromelain, and then we will actually do that experiment for you in the course of the next week. All right, thank you.